Latent heat. Latent heat Q is the amount of heat absorbed or given out by a body during change of state at a constant temperature. Latent heat Q is equals to ml, where Q is the quantity of heat, m is equal to the mass of the body, I is the specific latent heat. Unit is joule. Specific latent heat of fusion. The specific latent heat of fusion of a substance is the quantity of heat required to convert unit mass from solid to liquid without change in temperature. Latent heat Q equals to ml. Therefore, L is equals to Q over m joule kilogram per kilogram. The unit of specific heat of fusion is joule per kilogram. Calculation on specific latent heat of fusion. Heat given by calorimeter and water on cooling is equals to heat used in melting ice at constant temperature plus heat used in warming the melting ice from 0 degrees to T2. In bracket M1CW plus C close bracket open bracket T1 minus T2 close bracket is equals to ml plus mcw in bracket T2 minus 0. L fusion is equals to m1 in bracket C1 CW plus C open bracket T1 minus T2 close bracket minus mcw T2 all over m, where L is specific latent heat of fusion, C equal to the thermal capacity of calorimeter, T1 is equal to the initial temperature of water, T2 is equal to the final temperature of the mixture, M1 is equal to the mass of water, CW equal to specific heat capacity of water, and M equals to the mass of ice. Example 6. A calorimeter contains 600 grams of water and 100 grams of at 0 degrees centigrade. A piece of hot metal of mass 1 kilogram is gently added to the mixture in the calorimeter, and this causes all the ice to melt. Calculate the initial temperature of the metal, taking the specific heat capacity of water equals to 4.2 times 10 raised to power 2 joule per kilogram per Celsius. Specific latent heat of fusion of ice equal to 3.36 times 10 raised to power 5 joule per kilogram per Celsius. Solution. Let T degrees centigrade be the initial temperature of the metal. Heat required to melt the ice at constant temperature is equals to ml. Is equals to 0 times 0.1 times 3.36 times 10 raised to power 5 joule. Heat lost by the metal in cooling from T degrees Celsius to 0 degrees centigrade, mc in bracket theta 2 minus theta 1 is equals to 1 times 4.2 times 10 raised to power 2 times in bracket T minus 0 is equals to 4.2 times 10 raised to power 2T. Heat lost by metal equals to heat gained by ice. 4.2 times 10 raised to power 2T is equals to 0.1 times 3.36 times 10 raised to power 5. Making T the subject of the formula, we now have T equals to 0.1 times 3.36 times 10 raised to power 5 all over 4.2 times 10 raised to power 2 is equals to 80 degrees. Therefore, the initial temperature of the metal is equals to 80 degrees Celsius. Example 7. 0.5 kilogram of water at 10 degrees centigrade is completely converted to ice 0.0 degree centigrade by extracting 188,000 joule of heat from it. If the specific heat capacity of water is 4,200 joule per kilogram per Celsius, calculate the specific heat of fusion. Solution: heat lost by water from 10 degrees centigrade to 0 degrees centigrade is equals to MWCW in bracket theta 2 minus theta 1, where is equals to 0.5 times 4,200 times in bracket 10 minus 0.